welcome to episode 6 of Cloud Code Life. I am Alf, and as always, I'm joined by my co-hosts, GPS and Rishabh. And today we have an episode that is directed to everyone that is starting their cloud journey today. And if you don't know what services to work with, what topics to start with, today we're talking about 10 cloud services that you need to know. And this is not gonna be specifically what we're not gonna try to do is like go very cloud provider specific. We're gonna tell you concepts. We said this many times that it's more important to know cloud concepts more than knowing the specific implementation for the provider, because that knowledge translates pretty well. So today we're going to be talking about 10 cloud services that are very important to know and that should get you very well started on your cloud journey. So today we are not gonna do the stand-up weekly stand-up anymore, and because we're also not gonna do the weekly content of the week, because we've decided to transition those to our TikTok channel and our TikTok page more than a channel. So if you'd like to keep in touch with us, make sure to follow us at Cloud Code Life on TikTok as well as Twitter, and you're gonna be finding more content related to the podcast and related to a lot of extra things on that. So given that, we can get started, and I guess the number one service that is super important to know about is virtual machines. And I guess that is a very, very key concept in cloud, and not only in cloud, even on having knowledge of working with virtual machines is paramount, I would say.
Do you remember like deploying your first virtual machine and then SSHing into it, and you feel just like, wow, like I'm ultimate hacker, like you can't tell me anything. Do you remember that feeling?
I remember having like the whole keys and like not being able to sign up with the keys, and then I was like, oh my god. I need to do with PuTTY, because I was on Windows and like actually when I made it work and I was signed up, I was like, oh my god, no way. Like this is like magic and similar, but it's like so fun. It's a memory that like whenever it works and you're like, oh my god, now I'm in the servers of AWS and like and that was crazy, and like I'm a hacker man.
I think I had that hacker feeling when, you know how you have security groups, and this was my first experience trying to get or SSH into the machine, and I couldn't. And then I searched like where to look at, and then it said, oh, make sure you have port 22 open for your own IP address. And that was when I felt like, oh, I am a hacker, because I just opened up a port and now I am able to access a server.
It's fulfilling in a way, right? Especially being one of the services that I think most beginner cloud tutorials are aimed towards finding your way around using virtual machines. So, and we've listed the, oh, by the way, the sort of the format that we're going to follow is Alf will be pointing out like the AWS equivalent, and I'll be pointing out the Azure one. Rishabh's going to point out the GCP one, and then if there's any sort of maybe cloud agnostic one that's very popular, very used, we'll point those out too. But like most beginner tutorials being like the first, it's so easy to get hands on with a virtual machine and like deploy one and then destroy it and that kind of stuff. So yeah, good memories.
Yeah, and just to follow on to that, I think I followed some kind of tutorial where you had to have a node server deployed to a VM. So I think that was my first tutorial that I followed, and it involved just a basic virtual machine that would have port 80 open for your node site.
And not only that, also for Terraform, for example, like my first Terraform tutorial was deploying an EC2 using Terraform. And I feel like, again, given that VMs are like the backbone of a lot of other cloud provider, like cloud services, like most of the serverless things that you do are actually running on VMs. They're just not handled by you. So like it's just extremely important to have a knowledge of like what are they, why would you want to use them in your stack, why would you want to use them in your infrastructure, and how to work with them. And another thing that is like very closely related to VMs are the concept of load balancing and autoscaling. And I say that they are closely related because, for example, in AWS, they are a sub-menu of EC2, which is the VM service on AWS. And they are load balancing and autoscaling are a subset of EC2. And specifically, load balancing is just basically instead of connecting directly to a machine, you're connecting to this service that automatically sends the traffic to one of multiple machines. So that if you have like 1,000 of people that are connected automatically, you don't have all of the people on one single machine, but the load is balanced among the various machines in a smart way. And while the auto scaling is just saying, oh, we have traffic incoming, we can't handle this new traffic, let's just create automatically a new machine that can handle the new incoming traffic. And usually auto scaling and load balancing are used together. So when you don't have enough load balancing, you create a new machine. When you have more than enough machines, you bring down another VM, like you remove them from the auto scaling group, and then you rebalance the load across the other machines. So I think this is another concept that is very useful to know, also because it's one of the very key concepts of like the 3-tiered applications that you're gonna be talking about in a lot of like technical interviews if you're doing any cloud architecture role, probably, because it's such a basic style of application, just front end, like a front application with servers, a database layer, and an application layer. You have like your 3 application layers, and it's a very common interview question.
I don't know if I think GPS would be a good person to answer this, but I am pretty aware of AWS having a service as load balancing. What is the equivalent in Azure?
Like, I'm pretty sure it's like for first you have the actual like load balancing scale set, auto scaling, all of that inside of when you deploy your VM, and now you'll assign the rules like, hey, when this is the percentage or whatever metric you want to utilize to scale. Yeah, I think they're called scale sets or scale groups. No, I think scale sets sound familiar. Yeah, but it's also like it's similar to EC2. In Azure, we just call them virtual machines because we're very creative. But yeah, it's kind of like a default setting that you can, as you're deploying one, it's like, hey, do you actually want to set this up? Unless you actually want to just set up one for like a development thing or something like that. Yeah, it's actually pretty cool. Like, I think out of all the services, this might be one that across all clouds, or well, maybe the top 3, it's pretty similar. Not too, like, you could find your way around. Like, if you did it on one, you could find your way around the other one pretty easy, pretty straightforward.
I'm pretty sure also because it's such a foundational cloud block that is like there is really no reason to reinvent the wheel cloud to cloud. And a virtual machine is literally, again, it's a virtual piece of a computer that just you use to spin up and work on while being hosted on another physical machine. So there's really not extra steps involved in virtual machines that like a cloud provider needs to differentiate itself from other providers, I think.
Yeah, and to add to Antonio's point, I think like the concept itself is pretty like built into cloud. Like, this was the foundation because you're able to scale really easily with cloud. And also, I think going back to that fulfilling experience, I remember when I first set, I think it was an elastic load balancer in AWS, and just going through the UI and finding all those checks, and also like the service itself does health checks for you on your listed servers to determine which one is healthy and where to send the traffic, was just like amazing experience.
Yeah, Yes, it's good to see that's actually pretty straightforward across all. Do any of you actually deploy VMs or infrastructure like frequently or in your day to day kind of thing?
I do.
I don't specifically most of what my team uses is AWS batch. So we do less about VMs and also like Fargate is the other major thing that we use. Like my data team uses batch and engineering team uses Fargate. So less direct handling, but the underlying service is still VMs anyway. So
Yeah. And in my case, we do have our legacy apps that are still running like on Windows IIS servers. And we don't even use like the cloud provider load balancing solutions. We have our in-house Nginx configurations. So we have, I think, around like 6 Linux servers in front of those Windows VMs that are just there to load balance stuff. And I remember, like on a newer project I was working through Elastic Load Balancer in AWS, and I'm like, this is so easy here because I don't have to deal with misconfigurations or if I missed something and restart Nginx and stuff like that. And also, we have to make sure that the Nginx configuration is updated dynamically whenever there is an instance change. So all that solutions that are band-aids that we need to have in place for an in-house solution is just too much task, and it's hard to support it even like when new engineers come in because you have to like make sure there's proper documentation. But yeah, I do deal with VMs a lot in my day-to-day.
well, I think that then we can actually. It's a good time to move to the next really key service because, as we said, there are like really 3 layers to an application, and the next layer, other than the presentation and the application layer, would be the database layer. Most databases usually start with a relational database, so knowing your way around a relational database is an important skill for any level of engineering or tech, I believe. And like SQL is a little bit everywhere, and you don't have to be a SQL master to know how to work with a database, but you have to know the services. You have to know your way around the database overall. And in the AWS case, the database service, like relational database service, is RDS, which stands for Relational Database Service, and it offers like most of the names that you hear around are usually Microsoft SQL, which is like SQL Server. You hear Oracle, you hear Postgres, you hear MySQL. Sometimes you also there's others like MariaDB, which is from the I'm pretty sure it's from the same guy that made MySQL, and he's just changing the names of it. Like they're all for the MySQL is for his daughter her name is Mai, and MariaDB is from the daughter her name is Maria. So yeah, it's the same guy that like actually started both databases. So it's not MySQL as in my own SQL. It's the sequel of my. Fun fact of the day. But yeah, and then RDS also has Aurora DB, which is their own, like it's compatible with both MySQL and Postgres, which is their flavor of like a more optimized database solution that is like fully managed and such. Or there is even Aurora Serverless, where you don't even have to care about the VMs, underlying VMs. They all do everything for you. They handle everything, scaling and such for you. And it's a very innovative way of handling databases compared to the regular offerings, because a lot of people know that like the pain in the database is the configuration. And database configuration has always been a pain. I deal with I work when we have to organize our stuff, and my wife's mom is a database admin, so she works into that every day, and I would never wanna deal with that really. Too much headaches.
Yeah, Azure has Azure SQL, but we have like managed, or you could host it on a VM. There's certain images that you could use depending on what you want to manage. There's also Azure SQL Serverless, which is you pay for whenever you're actually running, so you don't have a dedicated 24/7 server. What else do we have in SQL? Azure SQL or Microsoft SQL, I guess. I think those are like the majority of them. It's merely up to like the how much you want to end up managing the server, right? And like you mentioned, managing that is like just a pain, especially when you don't have automated scripting tasks to actually handle things. And like because sometimes we would have like two databases on two different servers, and I'm talking about when I was a sysadmin, and they would make one change in one database and it was supposed to replicate across all of them, all the instances, but it for some reason never worked, and you would have to manually go in and do that, and that was just like terrible. Yeah, so having stuff that's like managed and set up correctly is the way to go.
Yeah, so I think I'll go for the Google Cloud solutions for relational SQL. So we have bare metal solutions for Oracle, and then I think the most famous one is Cloud SQL. That is your managed MySQL, Postgre, and the Microsoft SQL Server. And we also have, I think, Cloud Spanner, it's called, which is like cloud native, and it can scale to like a really larger scale, basically. And I think it has like 5 nines
I've never heard
as
of
availability.
that.
Yeah, I think it's called Cloud Spanner.
Yeah, my old company used to use Cloud Spanner.
Fantastic. I think this is another one. Is like one of the most essential aspects to cloud. So across all of them, I think they're going to be just like the virtual machines, pretty straightforward in terms of like what settings you have, like which flavors and how you can deploy them and that kind of stuff.
Yeah, I believe that the point of Cloud Spanner is like distributed and super scalable compared to like managing like your own database, like scaling your own database manually. And I also know that it's actually pretty expensive. I remember like the major part of our bill was Cloud Spanner.
I have to look into this because the name sounds pretty cool.
Oh, by the way, yeah. Managed SQL can get really expensive, especially with any cloud providers. That's a really good tip, Antonio, for anyone who is trying different services in the cloud.
It is the most of the time it's one of the largest expenses in cloud bills. We would have to ask Corey Quinn about this. Like, don't quote me on that, but we will ask him. But yeah, there are some horror stories of someone that like spins up like an RDS instance just for a fun thing, and they come up with like a $3,000 bill after a week because they forgot to turn it off. And yeah, it's a pretty intense experience.
So this might be one of those on the list that it's good to know about, not necessarily your go-to for like a beginner project. What do you think?
Yes, I think there are actually a lot of services that are like still cloud-based, like as in you don't have to manage your own things or spin up anything locally or similar. For example, there is a Heroku database that is like free, and there's like a free gigabyte, and it's a Postgres based, I believe. There is a Supabase that gives you less space, but it's free forever. And that gives you like a very cool UI to interact with your Postgres SQL database. And there are other, I think the Netlify also offers some database database as a service. But yeah, like the RDS is all like RDS, not only RDS, but all the relational databases on cloud, like the offerings, you want to start looking into them only when you have like more like structured projects that want to live on one cloud, and then you actually need to use the built-in solution for a database. You can spin, as Gwen mentioned, you can technically spin up your own database using VMs. Like there are images that are ready with a database, but the thing is that loses the benefit of having like fully managed services. But it's like it costs less, but it's more. It depends where your costs are. If your man-hour costs are lower than your like the managed service costs, then you should go for managing your own database and have a person that actually handles that day to day. Otherwise, if you don't have like the resources or the people or the time to manage that, you should pay more. But then you have a fully managed service for you.
Yeah, and that brings up a good point of how like easy the backup and other like disaster recovery solutions are with these managed services, especially for database. I think I've heard really bad horror stories. If like someone had picked a managed service, it would have been avoided, because you need to build or you need to plan a solution when things go wrong, especially with databases where the data is really essential for the business.
It's like I was saying, like we had to manually replicate things at the middle of the night on our things that were not set up correctly. I was going to mention this at the last point, and maybe for this specific this I guess bullet point, we don't have like a project idea, but just to like sort of backtrack just a little bit, do any of you have like project suggestions for each one of these services? Like for the virtual machine ones, I think maybe deploying a ghost blog might be a nice way to get some hands-on with virtual machines. And you can deploy the open source, like the free version one, on a pretty like low end and VM, and you don't necessarily have to keep it or anything like that, but it's just a nice way to get hands-on with virtual machines. I don't know if you all have any other project suggestions, but it might be nice to when we can offer them for each of these services that we're talking about.
Yeah, absolutely. I feel like for VM, like the very entry level, they will ask you a lot of the time if you have to do any projects. It could be even just deploying an Nginx server on a VM and just serve some static website from the VM. There's many projects that you could use, but it's just like simple deployments where you can like write your own like start scripts, so they automatically downloads all the packages it needs and downloads all the repos that it needs to download and similar. Those are very simple projects on VMs. On relational databases, there's not really projects that are so easy, because there is always this risk of overpaying for nothing. Like there is a free tier on AWS for RDS, but it takes a long time to set up, and you don't really have much benefit from the point of view of like building. It's just like putting up a database, set up a database, put in a table that has like 3 users, write a SQL query that creates a table and inserts the records in the table. That would be the biggest project idea that I can think of. But it's always a database is the part of the stack that is always in favor of something else. So if you don't have another part to a project, the database itself is always more on the database management that maybe you're not interested in, and not a lot of people really handle, because it's either managed or ready for you, or there is a person that is a database administration that does it for you. If you're a database administrator, like, go for it. Then you have all the interest in actually spinning up something on a VM, and you can combine VMs and database and spin up your own database using a VM. That's a wonderful idea, but not a lot of people are database administrator in like cloud based, or at least not at the beginning of your career.
Yeah, and I think that reminds me of one project I did. I think it was like some sort of library system where you could store PDFs along with your, like I stored the user stuff, and then each user can upload their PDFs if they're registered on the site. And that involved just like the managed service. I think I did that in Google Cloud. But again, that was just for, I think I let it run for like 10 days and then it started costing me money, then bringing more value to my portfolio. So I like shut it down, and I'm like, whenever they need to see this project, I can just fire it up again. But yeah, I think they're not such great examples for at least for beginners to do projects with, especially with the managed services for databases.
Well, there are project ideas though for the next item on the list, which will be object storage actually. So object storage is like the hard drive in the cloud, kinda, more or less. You can think of it, and there are like very famous players in the space of object storage. Like on AWS is S3, and S3 is like ubiquitous. Like everywhere you go you can find like S3, like most like a ton of website that you encounter or use like store their data, like store their objects, videos, images, anything on S3, and it's super common. And so object storage is nice to, like, there's to actually know how to handle properly your buckets, because I think it's pretty consistent. Like it's called buckets a little bit in all of the clouds, right?
In Azure, it's containers.
Yeah, it's containers in Azure, and then
they went.
What is what is it called in Google Cloud? It's called buckets.
I think so.
I'm pretty sure.
Yeah, it's called storage buckets.
Yeah, because it's like containers. Then you get confused and like another container stuff and similar.
Yeah, I get it.
But I think for example, one of the major project idea that I would have, especially for like AWS, where it's like very like enabled by default, is like storing a static website on an S3 on an S3 bucket. And I think you can do the same thing on blob storage or cloud storage. All the bucket objects have like the option to store, like to serve a website. So what you can do is like just build your own website, create a bucket, drop all the files in the bucket, and set up your bucket so that you can accept incoming requests to the link of the bucket, and being able to actually serve the files inside of the bucket as a static website.
Yeah, and it will cost you pennies
or nothing. Like I think that my website, I had my website up for a year now, and I still haven't paid a single dollar in out of that like static serving, neither for that or like CDN. Nothing. Spent nothing in more than a year. So I mean, it's a single page website, but again, nothing.
Yeah, I remember one of our engineers on our team, he asked someone to do, like, his wife asked someone to do their wedding site, and they told him it would cost them around $5 a month. And yeah, so this engineer decided to just do it through S3, and I think he said he was paying 12 cents, something like that.
I was gonna say the Cloud Resume Challenge is part of it is hosting.
It's
It's based on this, and then now there's actually a GCP one. Like A Cloud Guru just released the GCP Resume Challenge. So there's Azure one that I hosted a couple months ago, and then the AWS one, which is the original one by Forrest Brazil. We'll link all those. But that project covers actually a couple of services that we're gonna continue talking about. But yeah, if you wanted to host this like static site, I was just gonna bring it up because I have my Azure Resume hosted, and I think it's like, I don't know, like 11 cents a month or something like that for the entire solution. You know, I realized, I think they call it containers because blob bucket sounds terrible. Blob bucket. That sounds terrible. Yeah. So that's probably why they said, oh, let's go.
Yeah, blob container.
Blob bucket. Yeah, that's probably why. Don't quote me on that. Just my thoughts. Yeah, in terms of other, also, isn't Dropbox just literally built on top of AWS? It's just like a nicer UI on top of AWS S3. I think I heard that.
I'm pretty sure that I think the Dropbox uses S3 as their like the storage solution. I'm not like, don't quote me on that. I'm not entirely sure, but I think I heard it. I think that would make sense for them to use them, because again, you can literally build a service out of making the S3 experience better. That's what a lot of like software, like there are software where you can basically just do a drag and drop to S3 buckets and just like in a better UI, and you pay like $19 a month to use it. And it's not because the S3 experience is bad, it's just because it's such a ubiquitous service that like making it anyway accessible, more accessible than it is, it would actually net you an opportunity.
Yeah. Yeah, I think Dropbox uses S3. And that reminds me of another company that I came across called Filebase. And they use, S3 compatible object storage, which is like powered by blockchain, but it's on top of S3. So, yeah, there are many different companies doing great things.
You could
with
also use
S3.
S3 or blob storage or cloud storage, GCP cloud storage as your own way of saving things, right? And have like I have one that's called public things. I have a container called public things, and then I have like a headshot there, a resume there. If I just need to like quickly access it or quickly provide it to someone, I could just give them the link. Yeah,
That's what I use. Yeah.
it's way cheaper than.
It's easy because you can just give them the URL. And
I think actually the Dropbox used to use S3, and then they built their own solution, but still use Dropbox for analytics and data
yeah,
lake.
I think they went data lake stuff.
Like the actual they used to store like if you put something on Dropbox, it used to be in AWS before. Now it's actually in Dropbox data centers, but they use their data lake as S3 as their data lake. So that I think that's how it is. But they used to be in S3.
Yeah, so they made a lot of money off S3 and like, all right, let's find out how we can probably like, yeah. All right, cool. What's our next one?
Next one is actually the serverless functions, the world of serverless functions, and there are basically serverless. Anytime you hear the word serverless, is someone else's server that you don't manage. It's not serverless, is more server management less. So this is like the big thing. Any service that is build a serverless is just you don't need to care about the servers, but there are servers, like, because it's not like it's built in, like it's not in the clouds, like where like all the computing is done in the clouds. It's just done in things that you don't see and you don't need to see and you don't need to care. And I think the poster child for all of that is AWS Lambda, because that's the most I think one is the oldest service that is like serverless, server functions and such. But there is like a myriad of other services that are serverless now in AWS. Like every service has their serverless counterpart, which usually is either it's not more expensive, but it's a more it may cost a little bit more per. It's a little bit complicated to talk about serverless and costs, because the serverless costs are more unpredictable, but they are less expensive than maintaining very high capacity and that you don't use. So you waste less, but potentially you have spikes of costs. And this is like a thing that a lot of people that are trying to go serverless are saying, and a lot of people that don't want to use serverless are using again, like as a point. It's like, I don't want to be unpredictable in my costs, but then they don't realize that like maintaining the peak level of capacity costs more, or like being in the peak where you are about to like autoscale and you can't meet demand at the specific point and potentially losing customers or having issues with your service. Those are all costs that come into play, and that serverless tries to solve. And like I think that Gwen is like the resident expert here in all things serverless as well. So
I would say not an expert, but I'm a big fan of it. So I have a like major bias. So my content is heavily around, and like sessions are heavily around serverless things. We actually said the word serverless in a couple things that we mentioned prior to this. I think we talked about a little bit in the Relational DB, because like you mentioned, some of these services will have like your typical on-prem models, or like your pricing plans and things like that, and then you'll have like a serverless or like a consumption plan or some kind of offering, because these big cloud platforms realize that some of these solutions out here, you don't necessarily need to run them 24/7, so you don't need to pay for a VM that's on 24/7. You could just pay for something where it's running, I don't know, 10 times a day for 30 seconds each time, right? And yes, it might be like a lot of power, but for that time, it's going to be cheaper than running it 24/7, like Al said. So yeah, serverless shines when you have sort of like no traffic and then peak traffic for a little bit and then back to no traffic. If you have like predictable patterns, you're most likely better off with a traditional setup. You mentioned AWS Lambda, probably like the OG, along with many of AWS services. But there's Azure Functions. I put Logic Apps in here because Logic Apps and Azure Functions play well together. I think that's similar to like you have AWS Lambda and App Runner here. So yeah, they like Logic Apps is sort of like a visual like workflow orchestration for serverless, and you can connect APIs and data and your own functions and things like that. So they tend to play well together. So I put them there. But I'm sort of like, lately if I ever need to come up with some sort of project or anything like that, my go-to now is like, oh, how can I make this with a serverless architecture and take advantage of that, usually. But it's not like the absolute best for every single thing out there. Also, because you have to deal with like cold starts, right? Because your functions are idle for the majority of the time, and that initial call to your function is there's going to be a latency or going to be a lag there. If you can deal with that, by all means, like serverless is probably for you. But if you can't, if timing is absolutely critical, it's probably not something that you will. It's probably like a bullet point against serverless. But yeah, even now you can develop around cold starts, and you can figure out ways to make sure your function is always warm, or call it every time like a dummy call or something like that, and such. But yeah, I'm a big fan of Azure Functions. I have a lot of content around it if you're interested. In terms of a project to build, I'm still gonna say the Cloud Resume, because it's such a practical and easy way.
It's a part.
Yeah, it's a part of that too. So Cloud Resume has object storage, serverless, CI/CD, which we're gonna get into there. What else is in there? Oh, NoSQL is also in there.
Infrastructure
as code is in there. Yeah, there's a bunch of other things. So we're probably just gonna keep mentioning
CDN.
Yeah, you're right, CDN. But there's a bunch of things in there. That project that hits.
Yeah, honestly, the Cloud Resume Challenge is such a good all-around project for anything cloud, that is both an opportunity for you to showcase your resume in a better way than just putting it on paper and sending it via email, and actually getting exposure to a lot of cloud services. And literally almost all of the cloud services that we're talking today will be in the Cloud Resume Challenge. And if you read it and think that it's easy, I would say you're in for a ride, because it's not that easy. Unless you're this major expert with years of experience, then it might be to a degree trivial. But there are still like some fun like intricacies here and there that even if you're not even if you're an expert in certain fields, you might be tricked upon.
What was two questions here? What was the hardest part when you were doing your own resume challenge, whether that be the AWS or the Azure one? And two, we need to come up with our own, like our Cloud Code Live challenge. And it'll be something that covers a bunch of different services that people can get hands on, perhaps beginner friendly. Something maybe not a static site, maybe, I don't know. We'll think about it.
It should also cover Cloud Code and Life aspect.
Yeah, definitely. That would be so cool. But anyway, yeah, what was the hardest part when you were working on the resume challenge? For me, it was the freaking GitHub actions and getting the static site was pretty straightforward to get deployed to blob storage. I think the hardest part was getting the function to correctly run the tests. Oh, there's also testing there. Run the tests and then also deploy correctly to Azure. It was mainly because you have to run the GitHub action every time, right? You can't. There's no way to locally do it.
Yeah, for me, it was the Cosmos DB trigger, I think, because in the Azure resume challenge, it involves Cosmos DB because you need to update the viewer count. And in order to reflect that viewer count, the data is stored in Cosmos DB, which has to be updated on the static side. So I couldn't get the trigger to work properly, and I went through a lot of learn documentation, but I still couldn't. And then I don't know what different I did, but instead of deploying the function like locally, I just deployed it to the cloud, and all of a sudden like everything started to work. So to this point, I don't know what caused it to work, and that's like I just can't be in peace with that because I need to know what I was doing wrong.
I'm actually doing a video about that piece, just the
Oh, okay.
that
would be nice.
Not the whole, just that piece, using the function to pull the data from Cosmos and then updating it. I'm gonna do a video soon, probably this weekend, so maybe that'll help. Oh, we're using .NET 5 too. So
yeah, for me, for the AWS one, I didn't do the forest challenge because back in 2019, I already had a resume that I was serving through S3 as a static site, and this was for my cloud role interview. And so I was like, I already have something similar. I don't want to do it because, again,
was it similar though?
It was, but it just involved like CI/CD part and just a static site.
Okay, cool.
And I told Forrest about it, and he was like, "Oh, dude, I'm so happy for it because I got the role with that project." But the thing is, he was like, you need to do the actual challenge because it involves a lot more services. And I'm like, yeah, I don't have the bandwidth to do that. But yeah, no, the Azure one was fun.
Alf, how about you? What was the hardest part?
For me, it was to get SAM template to work. Oh my god, I feel like after doing that, I learned Terraform. And that was such a better experience compared to like SAM. Like I love what the SAM team is doing because it's all the SAM. By the way, is the serverless framework for AWS. Is the specific to deploy like serverless applications. It's called SAM. It stands for Serverless Application Model, but it's kind of like convoluted and it technically invites you to test locally, but I was almost never able to test locally. So it was just like a very, very weird experience, and it took me basically like 70% of the entire time of the challenge. I spent like in hours on the challenge. I spent it on like making the SAM template work. And if I were to be able to use like Terraform, it probably would have been like, if I knew Terraform at that time, would have been so much nicer. And I think I can redo the same thing in Terraform in a significantly faster time. But like working with SAM was pretty intense.
Good to know. In case I ever do it, I'll keep that in mind. Don't think I'll ever do the AWS one though.
Well, the next part, which is also included in the Cloud Resume Challenge, is a NoSQL database. We talked about relational database, the more like a SQL-friendly type of database that you think with schemas and such. But there's also, especially in the modern web development in web apps, NoSQL is a very important skill to have. If you think MongoDB, if you think DynamoDB, Cosmos DB, Firebase, all of these services, they're all NoSQL services. And it's very important to get the grasp or if at least one of these services work. In AWS, there's like the older OG, like super scalable DynamoDB, and which is very, very it's one of those things that is easy to learn and hard to master. Like it's easy to work with DynamoDB, but like learning the intricacies of DynamoDB, like single page design and all of those more complex topics around designing very very scalable structures in DynamoDB is very hard, and that's why there are like very good people like Alex Debris to actually write whole books about DynamoDB, and that book from Alex is wonderful. And you should actually check it out. It's gonna probably be in the show notes. But I would say that if you learn DynamoDB well, and as Forrest Brazil once said during the Cloud Resume Challenge, if you know DynamoDB well, that's a job position for you on its own.
I think data in general, knowing how to, I guess, master it in the cloud is an entire area and expertise on its own. Like your whole role could be just around that. Whereas the other ones, I guess, could be a little bit more general, right? But I don't know. Personally, I stay away from data just because I just wouldn't know where to start. Besides your basics, right? For NoSQL, we have Azure Cosmos DB, and Azure. It's this might be another one of those services that are pretty, not pretty standard, but pretty similar around all the major clouds. Cosmos has support for, I think you mentioned a couple of them. Mongo, there's Gremlin's another one, I think. I'm trying to think of the ones that you haven't mentioned. What's cool about these NoSQL services is a lot of them have great sort of like ways of interacting with like serverless functions. So for example, Rishabh was just saying that you in the part of the Azure Resume Challenge, you have to connect Cosmos DB to your Azure Functions to update some data, and you can do that declaratively using bindings and triggers and things like that. So it's really cool for like when you think about you need to build a solution, you need to store your information somewhere. You can pair it along with like you have your function, and then you have your NoSQL, whichever one you choose to use, and then you have your your not blob storage, what's it called, object storage, and you have sort of like your three things that you need there for your backend. Not much else to add here. Is when it's I find this it's great. There's also like a serverless like a pricing, so you're only paying for when you're actually interacting with the data. But again, data for me is something that's like it's a thing there. I don't really try to go too much in depth with it.
Yeah, for GCP, they have Cloud Data Store. I think the newest one is Firestore, which is part of their Firebase offering. I could be wrong on that, but don't quote me on that. But yeah, it's pretty similar, like Gwen and Elf said. Just like NoSQL concept of there's unstructured data, and I also feel like we are seeing a trend of like new applications that are coming out. Are supported by NoSQL databases on the back end. I think I don't know what's driving it, but I think like the pace at which you can develop a NoSQL database is like faster, especially when you're managing and doing stuff yourself in SQL database. But yeah, as Gwen said, we are no experts in data. Antonio, what are your thoughts? Like, why do you think there's more shift towards NoSQL?
The thing about NoSQL, in my opinion, is always that you don't have to commit to anything early on, compared to whether if you have a database that is like a relational database, before you even start creating data, you have to create a schema, and you have to create a definition of the relationship that exists in that schema. So if whenever, and this all the database admin people know, is whenever you want to add a single new column to a database, or you want to add create a new relationship, it starts to become very painful, because there is a lot of work, and there's a lot of variables involved in a SQL classic relational database environment. While NoSQL, given that it's all document oriented, or is like more object oriented, there are no fixed schemas. So if you need to change a document, so for example in MongoDB, it's all basically saved as a JSON file. It's not exactly a JSON file, but it's like very akin to a JSON file. If you need to, from the next objects, you need to add a new key or something, you just add a new key. Like there's no requirements for the previous documents to have the same key as the next object, while that would be a requirement if you had to create a new column in a relational table. So I think that's why there is the flexibility when it comes to NoSQL in the new application, is because there is less commitment up front and there is more scalability and more ease of changing course of action midway through everything. I think that is one of the powers of NoSQL, but that's also one of the drawbacks of NoSQL. Like you don't have like a kind of like a path to follow. Like you can go everywhere, and that kind of gives you the choice, the choice hell, like where you never know what is the correct decision. You may be stagnating between whether to go in certain direction. So it's always like, again, like in a little bit like every single service on the cloud, it's always like about you have to trade-offs. So there are trade-offs in like how easy it is to join data. For example, it's harder to join data in a NoSQL database compared to how easy it is to do in a relational database, because it's literally based on relations. In NoSQL doesn't work like that. So if you need to have multiple tables, it's harder to join them together, and that's why there is logic things like single table design, where all the data resides in a single table, and what you're trying to differentiate on is like the indexes that you use to create new partitions and such. So there is a lot of like trade-offs in deciding what type of database you want to use, but usually NoSQL is very good to start because it's less constraining and it's more quick to work with because it can grow as you go along.
Cool. I want to we're cutting it close on time, and I want to cover the rest of these because they're like super important. So if we like move into API gateways. Does anyone want to take a stab at explaining what an API gateway is? And it's interesting that they're all named. So it's AWS API Gateway, Azure API Gateway, GCP API Gateway.
It's one of the only services that has the same name across the entire and all the services. Actually, that's very fun. It's because it's like such a it's a standard thing. Like API gateways are on their own, like you can build your own API gateway, and that's a name on itself. Like an API gateway is just like a way to organize API endpoints and managing your API endpoints through one single layer instead of having like for example in the Cloud Resume Challenge, you will need to use an API gateway to call your Lambda to update your count and receive your visit counter back. So instead of calling the Lambda directly, you call it through an API gateway, through a GET request to counter or whatever you want to call it. For example, in the Cloud Resume Challenge, it's just that so there is a one single layer, one single endpoint to contact for all your API needs, instead of having to track every single API endpoint. That can be a Lambda function, that can be a VM, that can be any sort of service that provides an API endpoint. And as mentioned, the name is the same through all of the services, API Gateway. I know that the GCP has an extra one. There is like a more advanced one. I think
it's called APG, or I think that's how they pronounce it.
APIG,
APIG or APG. But yeah, I think it was part of, because it was a different company before. And I think it was in 2015 or 2016 when APG was acquired by Google. And that's why they're off like this, tried to stick with APG as the name. But yeah, the company itself was just API management and analytics, some sort of analytics too. So yeah, I think they named it GCP API Gateway, APG.
Do they both do the same thing?
Yeah. I think it's called APG, API management. I think how they refer to it now. Yeah, there was a lot of name changing involved.
I added the So Azure API Gateway and then Azure API Management. The API Gateway is like pretty much what Alf mentioned. It could be sort of like multi-cloud or on-prem, hybrid, those kind of things. Kind of like anywhere. So you have an API, you can put it in here. Have one place to like publish, secure, monitor all your APIs and things like that. And then you have Azure API Management, which I think the cool part of that one is there's serverless offering there, in terms of like how you pay for it, right? So you can take advantage of like if you're building an API with Azure Functions and you have like a bunch of endpoints there, you can use Azure API Management instead of API Gateway to sort of save on costs there. But it's more of like which one fits your solution better.
Yeah, and I think you're right, GPS about So they have another offering called API Gateway, and then API Management is a different offering by Google. Yep.
Pretty boring, I would say, but it's one of those services that important but boring. Cool.
There's positions that work only on those that's interesting. I guess it's interesting to have under your toolbar to know what it is, because again, most companies use APIs and most companies are fronted by an API gateway of some sort. So having knowledge of what an API gateway is and how you can interact with it, that's the key part of it.
Yeah, absolutely. Monitoring, which is the next service we have here. And there's interesting, none of these names are at all aligned or anything like that. AWS CloudWatch, Azure Monitor, again, very creative, and then GCP Cloud Monitoring,
which is the most plain.
CloudWatch is interesting.
They all do the same. They just look at events basically happening, and they just monitor the state of your application and all of your cloud services, and you can actually set up alerts. So when certain things happen, maybe there are some usages that go up, or some VMs go down, or there are certain situations that you want to keep track, like even budgets fall under the monitoring category, I would say. So like cost budgets, which is the thing that you should do first moment you open your console the first time. Set up a budget for like for your cloud provider, otherwise you're gonna be sorry later. And but this is like a simple thing. This starts falling under the DevOpsy side of things, I would say. And it's important, all this logging and monitoring, especially when your applications start to grow consistently and you want to keep track of how your applications behave, and being able to act promptly whenever anything goes bad. It's just it's a nice to know the fact that it's all of these on every platform. They are pervasive services. Like they are every single service on every platform is integration with cloud watching for AWS, Azure Monitor for Azure, and cloud monitoring for GCP. Like because it's such an important part to know how your application is behaving. And so the project idea would be just to create your budget and have a notification whenever you go out of budget, which is not only the project but is a must do. I would say. But there are other monitoring projects that you could do, like for example in your Lambda, whenever you hit more than like 10 calls in the span of like a minute, that could be a simple project to put together. But it's like just gives you an idea of how are these monitoring tools used and how they can be set up.
Yeah, and then you can take it to a next level by, like as Antonio said, so if like let's say your VM is running at 90%, send me an alert through Slack, because all these monitoring tools have some sort of integration with Slack and other tools. Like in our case, I know we use PagerDuty for when there are incidents we need to respond to after hours. So yeah.
Another thing you could potentially try is have your function, whether that be Lambda or Azure function, whatever it might be, sort of print to your whatever logging sort of mechanism your monitor has. Like we have application insights, so I would have a function that every time it executes, it just prints a little hi and maybe the date or something. Or actually, timestamps are kind of like a default, so maybe like, I don't know, some custom message, and send it to application insights, which is part of Azure Monitor, and then you can use KQL or custom query language to go find that specific message and things like that. So because understanding where you can find sort of these logs and things like that is also crucial. And another one of those areas where you can have an entire job and role related around monitoring and knowing where to find a specific alert, where to find, if something happens, like what's your first step, like to troubleshoot what's going on. Yeah, so a couple of project ideas there as well. Monitoring is a lot more fun for me, I think, because of, I don't know, Rishabh, if you've ever viewed the live metrics when a function is executing, like that whole dashboard. It looks.
I did.
It looks really cool. So I got into sort of wanting to understand more, specifically application insights, because of that really cool dashboard. And for demos, like I remember doing a demo of a solution that I built, and then that live metrics, like you literally see the console print out there and like the little spikes and things like that. So it looks really cool. So you look legit and professional when you're doing like demos about like your solution that you built to the rest of the engineering team.
Especially with production scale apps, yeah, you need better, like 100% coverage across every VM that you're running, and then also you need to have proper logging, because anything goes down, as Gwen said, you need to make sure where to look at.
It's kind of like when you know how you debug like code, you're coding something and you just print to the console, and then that's your debugging mechanism when you're getting started, instead of like using breakpoints and stuff like that. Yeah, kind of like that. Cool. So what's next? What do we got? CDN? CDN, Content Delivery Network. I think that's correct. So it's we'll call it, I guess, a service that you will utilize with your website, and then you can keep sort of your static data or files, assets. Let's say assets. Things that don't change as often there. That way, when someone goes and visits your web app, it's quicker for that stuff to load. More of your dynamic content you wouldn't necessarily keep there. And it's typically located closer to where or deployed closer to where. So you'll have the option to deploy it closer to where your customers are and things like that. Is that what else is part of CDN? I think that's like the biggest thing.
Yeah, that is completely what CDN is.
All right, cool.
There are a lot of offerings for cloud providers, cloud specific offering, but in this case we are more thinking about going in general, and I feel like Cloudflare is the biggest CDN, like it's the most famous as well CDN provider, and they have also a pretty generous free plan. So for your own personal projects, there are that gives you all things like DNS, SSL. They like a lot of workers. So for providing your data, it's a very, very generous free plan. And it is unlimited. It's not even a certain amount of time, like a first year that you use it. So it's an unlimited free. So if you're doing your own small project or your personal website and stuff, you wanna your personal website doesn't need a CDN in itself, but if you wanna work with a CDN and use it on your own personal profile, Cloudflare probably is one of the best solutions. There are other cloud specific like AWS, Azure, and GCP specific CDNs, but we felt like this was one of the services that might be more general and useful. The next thing would be learning a little bit of CI/CD, and we have the resident DevOps engineer here, so we can have Rishabh explain a little bit of what that is.
Yeah, so basically CI/CD, as in literal terms, means continuous integration, and then CD means continuous delivery. So basically, when they're part of a release cycle process. With a release cycle, I mean whenever you push out code or you are making changes to your code in the application, you want to make sure that you don't have to manually build your application and then copy or paste it to S3 or on a VM. So to avoid all of that mess, you have CIE part of it. So you might have a GitHub repo or any sort of other repository and version control system that your company might be using or you are using personally yourself, where you can commit your code. So it will also store your code, but also keep a history of what you have been making changes to. And also other people can commit to it and like make changes to it, which is the integration part of it. And it helps you not mess up the code when different people are working on it. And that there are some best practices that we can dive into in a different episode of how to use GitHub and repositories in general. But then the other part is continuous delivery. So how to deliver what you have made as an application to the end customer automatically. And our go-to service today is GitHub Actions. So basically I think it's a YAML. Does it support JSON too? I don't know.
I think I've seen most of the time YAML.
Basically, you have a YAML file in which you declare a few steps on what to do when there is a new merge request or pull request. So a merge request or pull request is basically when you want to merge your code that has been sitting in a different branch to your main branch in GitHub repository. And once that's merged, GitHub Actions would know what to do in order to deliver that app. I think that basically describes both the terms.
Yeah, pretty much. It's also another area that you work with in the resume challenge. So yeah, even another reason for you to go ahead and do that. CI/CD is like so frustrating, but once you figure it out and everything works as it's supposed to, it's magical, isn't it?
Yeah, I think it's the most fulfilling. Like, also especially with personal projects, it's the last bit that you do. That's how I feel. Like even with my work-related projects, this is the last thing we focus on. But it is also the most frustrating because there are just so many things you need to configure and figure out. Especially like there are environment variables. There is also access to the network where the application will be deployed, and all of that good stuff. And once you figure it out, it's just magical because now you don't have to touch any of the infrastructure part. And also, like, you just have to make changes to your code, and those will be deployed automatically.
Yeah, it's pretty. I used to use Azure DevOps, and it was pretty satisfying to see the little checks on each of those boxes as that you like completed the pipeline. Yeah, pretty cool. Yeah, but we all agree here, GitHub Actions, mainly because I think every beginner now is gonna have like a GitHub repo, and getting CI/CD implemented with Actions is just another feature in there.
And it's the easiest one to get started with because I guess it is the one that has the most readable configuration files as well. Like Jenkins is a little bit more intricate. You have to know certain concepts of Jenkins before you can actually start being very proficient with it. While GitHub Action is very very straightforward. Like there are steps and there are scripts for each steps and there are it's very very readable without having major knowledge of the underlying content and the underlying structure.
I also think people are really familiar with the UI itself.
Yeah.
The challenges I had with Jenkins was that I was not familiar with the UI itself, and similar thing with TeamCity and all of the tools that we have. Whereas with GitHub, because you have been using it for your personal projects, you're kind of familiar where to go look at and stuff.
The last service for today is, and it's not exactly a service, but it's like the thing on the top, like the cherry on the top, is actually infrastructure as code, and learning a little bit of infrastructure of code, which is the practice of expressing your infrastructure through code with very 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 self-description, self-descriptive. Is a way to have code that expresses your infrastructure instead of going in the console and manually starting a service or starting via the CLI and such, but instead having it via code that can be version controlled and then just automatically deploy following a specific plan. And again, here we feel like there are single cloud specific offerings, but I think that the most ubiquitous is actually Terraform, because it's cloud agnostic, and it's such a wonderful tool to work with. It's a very it has a specific language configuration that is called HashiCorp configuration language, and that is very readable, human readable, and it's beautiful to work with. And you can learn it very quickly. You can spin up your own infrastructure in Terraform using maybe like 15 lines of code. And it's also, as mentioned, it's cloud agnostic, so you can move the knowledge that you learn. Maybe you go through a course that uses AWS, you can learn the same exact thing by using, you can move your knowledge of the same exact things to Azure or GCP or Alibaba, or there's also like other things like Kubernetes, IBM, like there's a little bit everything, and not only cloud platforms, but also other cloud services as well. So if there is we're pretty confident in saying that Terraform is the best bang for your buck in terms of like spending your time in learning infrastructure as code, because again, you can reuse it everywhere, and it's also like an extremely well organized tool and such a solid developer experience.
Yeah, and I would just like to add, you can also do on-prem with Terraform, so vSphere and all of those other amazing on-prem services that you might use, you can have it declared as infrastructure as code with Terraform, which is pretty amazing.
Well, I think these are like the 10 major services as we mentioned, and just to recap, summarize, we talked about VMs, we talked about relational databases, we talked about object storage, we talked about serverless functions, we talked about NoSQL databases, we talked about API gateways, we talked about monitoring, we talked about CDNs, we talked about CI/CD, and we talked about infrastructure as code. I think having knowledge of what all of these are can get you pretty far in your starting journey, and you can take this almost as a list of like to-dos to start getting familiar with topics in the cloud. And I feel like it's a very simple list, because most of these can be found even outside of cloud, like on premises. Like for example, relational DB, you don't need the cloud for relational DB. VM, you can spin up a VM on your computer using what's the name of that, like Parallels Desktop, any or VirtualBox or any of those. And SQL database, same, you can locally start your MongoDB instance. So all of these are general computing topics, but they found their home very naturally speaking into the cloud.
I think we have a solid list here. I wonder if we could come up with a project that includes them all except for the SQL one.
We can potentially throw the SQL in as well if we really wanted to, but
that'd be wild.
that would be a wild project. But yeah, no, I feel like this could be a good fun to come up with an alternative to the Cloud Resume Challenge. Like, go check the Cloud Resume Challenge. We're gonna put the links for all of the 3 challenges, the AWS, the Azure, and GCP one, in the show notes. But definitely, if you are looking for a project to start, that's the one that will be a very good bang for your buck again. Very, very complete, and then you also have something to show for it.
Don't think it's too easy. I like you said, Alf, a lot of people are saying like it's too easy. It's just a static site. It might look like just a static site with a visitor counter, but the back end is quite difficult to piece together. So
I know that there are a bunch of people that were like, oh, the back end is easy, it's the front end that is the drama. Like, oh my god.
All right, I think we're good to wrap it up.
All right. Well, thank you so much for listening to episode 6 of Cloud Code Life. And again, if you feel free to follow all our pages, we are on Twitter, we're on YouTube, and we are now on TikTok. Follow TikTok for more content during the week and not only on Fridays. And for this said, thank you so much again for listening, and peace.